Make a bold.
Hello, everyone, and welcome to the second part of our IBM Code Engine series, IBM Code Engine 201, Deploy Apps from Source Code, Containers Made Simple. So today we're going to continue where we left off yesterday, where we did the bulk of our work in the IBM Code Engine console. Today we're going to be focusing primarily on deploying applications, provisioning some persistent storage with Cloud Object Storage, and doing some eventing and doing some other cool stuff from the Code Engine CLI from the command line. So thank you all so much for coming. I'm hoping to help end your week off on a fun note. So a few pieces of housekeeping to get started. If you look at the very top of the chat, I have all of the resources listed for you there. If you're joining from one of our social media, IBM developer social media sites, I have everything shared in the slides. So all of the resources that you will need are available in the slides. So if you're joining from, like I mentioned, any other social platform, you can get everything you need from the slides at ibm.biz/IBM-code-engine-201-slides. Yes, I know it's a mouthful. I'm working on archiving some custom URLs so I can shorten them back up for you. To answer your question, yes, the live stream is being recorded. You can access the live stream recording immediately following the event at crowdcast.io/IBM-code-engine/2. So actually, if you join Crowdcast at the crowdcast.io IBM Code Engine, you can access both parts 1 and 2 from within the same window. And as always, if you would like to follow along today and get hands-on, feel free to sign up for an IBM Cloud account. You will need a Cloud account if you would like to do all of the provisioning and deployment that we're going to do today. So you can sign up for an IBM Cloud account at ibm.biz/IBM-code-engine-201. If you are, oh, there we go. If you are currently logged in to Crowdcast and you look to the bottom of your screen, you'll see a little green button that says IBM Cloud Sign Up. You can go ahead and click there to sign up for a cloud account if you haven't already and would like to follow along. The tutorial we're going to be doing today is the thumbnail tutorial. You can find that within the Code Engine repository at github.com/IBM/Code Engine. And you can find the thumbnail tutorial as well as other sample apps and great tutorials in that repo as well. So if you haven't already, feel free to share in the chat your name and pronouns, what title company you work for, maybe what program you're currently enrolled in, where you're from or joining from, something you love, and maybe a quirk, something that's uniquely weird or different about you. So I'll go first. For example, my name is Jenna Ritten. My pronouns are she, her. I am a cloud developer advocate at IBM. I'm originally from and currently joining from Detroit, Michigan. And something I love, change it up a little bit. Something I really love is travel. I'll lead that with I guess I'll follow that up with my quirk. I have studied abroad in Spain twice, and I've also spent a summer in Israel as well. Looking to add more stamps to my passport book. So if you have any recommendations, feel free to send them over to me via LinkedIn or any of my social platforms. You can contact me at jritten on all social platforms. If you need to get in contact with me for some reason or just be able to find all of the resources as far as slides, any past workshops, you can do all of that from my Linktree, which is linktree/jritten. Okay, in honor of Hacktoberfest, first I would like to wish everyone a very happy Hacktoberfest. It is my personal favorite time of year. I would also like to wish those that are celebrating a very wonderful end to Hispanic Heritage Month, which ends tomorrow. And we're right in the middle of Breast Cancer Awareness Month as well. So lots of cool things going on. I highly recommend certifications, especially ones that are free. So here are some of my personal recommendations that I've worked through myself. So if you go look at my LinkedIn profile, you'll see all of those, all of these same ones there, as well as some other ones. So everything from cloud native development, how to get started with Docker, IBM Cloud foundational skills, anything you need to get up and running with cloud native development, we have a badge for. And again, they're always free. And it's not one of those things where you do the course and you have to pay for the certification. You get a badge and a certificate of completion at the end to do with what you will. Completely free, no card required. So before we get started, I would like to let all of you know if you have any questions at any point in time, we will be answering questions in the chat. So we have some support available for you. So feel free, if at any point in time you get stuck, you get lost, you have a question, go ahead and post in the chat. There's also an ask a question section at the bottom. We have support, dev support in the chat there to help you and answer any other questions that you might possibly have along the way. Also, if you're following along and you get stuck at any point in time, you can always go back and reference the Code Engine repo. All of the steps that we're going to be doing today in the tutorial are within the repository as well. So we're going to get started with a few high-level introductory pieces. We're not going to go too into depth. We covered a lot of this yesterday, but just a recap, a refresh on what we're going to be doing today. So we're going to be working a lot with containers. So for those of you who might be newbies trying to get your feet wet this Hacktoberfest month, what we're going to start with is containers. So a container is just a standard unit of software, packages up all of the code and all of its dependencies so that applications can run quickly and reliably across computing environments. So whether you're working on Windows, Windows-based Linux, Mac operating system, containerized software always runs the same regardless of the underlying infrastructure. And it can do that because containers isolate the software from its environment to ensure that it's working uniformly despite any differences, for instance, between development and staging, for example. So if that's what a container is, what's a container image? So a container image is a lightweight standalone executable package of software that includes everything needed to run an application. So the code, the runtime, system tools, system libraries, and settings. And you might be saying to yourself, wait, didn't you just say that? I actually did just say that. So containers and container images are very similar, and they contain all of the same pieces of information necessary to run your application. So the main takeaway here is container images become containers at runtime. So in case of the application we're going to deploy today, the Docker image that we're going to be using today that's stored in Docker Hub in the IBM's Docker Hub is going to become a container when we run it on Code Engine. So once we deploy it to Code Engine, that Docker image is going to become a container when we deploy it to Code Engine. So if you don't take away anything else, that's really the key takeaway here. So what is a container registry? We're going to see this a little bit in the middle of our workshop today. But a container registry is really just a repository like GitHub used to store container images. So used to store container images like the one we're going to use today. So that could be anything from IBM Container Registry, as you can see here. That could be Docker Hub. That could be from other registries as well, like Red Hat's Quay. What's really nice about registries is not only do they act as a place to store container images and share them through a process of uploading to, called pushing, or downloading from, called pulling. In addition to container images, registries can also store API paths and access control parameters. And if you don't know what API stands for, which I think I used it much longer than I thought before I knew what it actually meant. When we're referring to APIs, we're referring to application programming interfaces. You probably have used some. An API, for example, would be map boxes. If you build an application, put a map in it, and you use Mapbox's Mapbox, their map API. That's an example of an application programming interface. So there's two types of container registries, public and private. IBM Container Registry offers the ability to store both public and private registries. And private registries are a great way to incorporate security and privacy for enterprise container image storage. And that can be either hosted remotely or on-prem. And private registries come with advanced security features and technical support. Great example being Red Hat's Quay. So what is Code Engine? Because that's what we're going to be focusing on today. That's where we're going to be working, deploying from, doing all the neat things. So Code Engine is a fully managed serverless platform that runs your containerized workloads. This includes web applications, microservices, event-driven functions, and even batch jobs. Code Engine can even build container images for you from source code using its built-in source to image feature. So what is IBM Cloud, IBM Cloud Code Engine? What can it do for you? So we're going to see a lot of this in action today. So some of the things that you'll be able to see is Code Engine can host any containerized workload in the cloud in a matter of seconds. This is, as I mentioned, web applications, functions, batch jobs, microservices. And what's really fantastic about Code Engine is that it auto scales up and down, even to 0 when idle. So when your application, your web application, your microservice is not receiving any HTTP requests, it's not receiving any traffic, it will auto scale to 0. So you're not incurring any costs while your application is not in use. Code Engine hides all of the infrastructure pieces. So it manages, scales, secures clusters, networks. All of these pieces are hidden from you in the underlying infrastructure. Code Engine builds container images from source code, from public and private repos and registries. So regardless of where you're storing your source code, whether it's in container images or source code from any repositories, Code Engine can serve it for you. It's integrated into IBM Cloud and all of IBM Cloud services. So it makes it really easy to integrate in any other IBM services you might already be using, like Watson Chatbot or Auto AI, machine learning models. It's already integrated into IBM Cloud, so you can hook up your services very quickly and easily. And lastly, it's built on open source software like Kubernetes, Knative, Istio, and Tekton. So it keeps those workloads very portable. And the best part, you pay only for what to use. So you're not incurring costs just for provisioning clusters. Those clusters will auto scale down, up and down for you based on usage. So let's set up our dev environment. So the first thing you'll need to do, as I mentioned before, if you're in Crowdcast, go ahead and click the button at the bottom. If you're just joining us on one of our IBM developer social channels, you can sign up for an IBM Cloud account at ibm.biz/IBM-code-engine-201. Okay, so once you sign up for your account, you will need to create an IBM Cloud pay-as-you-go account. So you will need to upgrade your account if you already have one. If you don't already have one, once you create it, you will need to upgrade your account to a pay-as-you-go account. Now, have no fear, there's a free tier. So IBM Cloud Code Engine has an always free tier. It's actually very generous. I actually use my my personal account for demos and testing and trying things out, and I have yet to incur any costs. So the free tier allows for up to 100,000 vCPU seconds per month, up to 200,000 gigabyte seconds per month, and it can receive up to 100,000 HTTP requests per month. So as you'll see too from the workshop yesterday, you can also check it out in the dashboard, any other projects that you create. From the Code Engine console, you can see the amount of resources that we use is really only a fraction of a percentage of what you're allowed. So you actually get quite a bit with the free tier. So we have two ways we can get things set up here. Yes, you need an IBM Cloud account. We have two ways that you can get started here. I'm going to show you how to get started locally. Initially, if you would like, you can run everything from the IBM Cloud Shell. So you won't need to do any of the installation of anything. So you can click on your Cloud Shell, which I'll show you quickly in just a second. At the top of your screen, you'll see a button for the Cloud Shell. And then what you're going to do is you're just going to enter IBM Cloud to use the CLI. So if you follow along in the slides too, it will take you click by click how to do everything. So once you type in IBM Cloud, you're good to go. You don't need to install anything. You don't need to do anything. If you would like to get set up locally, you are going to need to install the IBM Cloud CLI. I have the commands for Mac and Linux as well as Windows 10 Pro. So you can grab those from the slides. Then you can verify the CLI is installed. And again, I have the commands, all the commands in the slide. The next thing you're going to do is log into IBM Cloud via the CLI. So let me just go back here. Okay. So if you are curious, IBM Cloud Shell. So if you look at the top, you're logged into IBM Cloud. You can see next to the little calculator here, the IBM Cloud Shell. So if you click that, that will open up here. So for any of you that might need to install things to get started, or want a quicker way to do that, let me grab my, here we go. This here. All right. Oh, this is so provisioning. Okay. So that's how to get to the Cloud Shell. And again, as soon as you type in IBM Cloud, you are good to go if you want to work from there. I'm going to be doing everything from terminal today, from the CLI to show you how to use it, get comfortable with it. Okay. So what we're going to be focusing on today is the Code Engine thumbnail tutorial. So I'm gonna give you a brief recap, and then I'm gonna help you get all of your initial things set up so we can get the workshop going. So the Code Engine tutorial is uses Code Engine. It walks through a common pattern of how applications will change over time from just a prototype to one that can then be used in production. So to keep the example simple, we're going to create an image transformation service that will quote unquote process an image by examining it and create a thumbnail version of it, hence thumbnail generator. So the code itself to do this, to do the transformation, isn't really the point of the tutorial. Rather, it's the growth of the infrastructure around the application and how Code Engine makes that much easier. So the overall growth pattern that the application will take is we're going to deploy a simple web application as a prototype to prove that our core thumbnail processing logic and functionality is working. Everything is self-contained in this one web application. So we're not going to be running multiple microservices. Then we're going to add some persistence so that as images are uploaded, they're saved for safekeeping, and so that we can offload the processing to a background process, since in many scenarios, the transformation logic can take a while. So this also allows for other mechanisms aside from our web application to upload the images. For cases where the data being processed could be coming from multiple sources. And finally, we'll convert this offline processing into something more event-driven so that we can process the images in real time and see those changes in the application immediately. So let's get set up here. So the first thing you're going to need to do is make sure you are logged in to your IBM Cloud account. So you're going to just type IBM Cloud login. Okay. Then you're going to log in to your account. Okay. Okay. There we go. Okay. So as you can see here, I already have my region set to EUGB. So, you can work in any of the regions. So we have US South, and any region that is closest to you, or maybe closest to where your other workloads are located. We have regions globally. If you need to change your region for any reason, you can type in IBM Cloud target -R, and then you can just type in you can see all the different regions here. And then to select one, you'll type in IBM Cloud target -R EUGB. That's what I already have selected. Just make sure you can see. Okay, just want to make sure you can see my terminal. Okay. Okay. Now the last thing I'm going to need to do is I'm going to need to target a resource group. So if you type in IBM Cloud resource groups, move this to the top. If you have a new account, or you've only been working on a handful of projects and you haven't created another resource group, you should only see one. So you should have a default resource group from when you signed up for your account. So what I'm going to do is I'm going to type in, if you scroll up, you have the command right here. Okay, so I'm just going to type IBM Cloud target -G, and then I'm going to give it my resource group. Okay, so now we are good to go. So we have everything set up the way we need it to get started. Before we begin, let's first discuss how the image transformation of our thumbnail generator works. So it's pretty simple. It takes an image as an array of bytes, and then it returns the thumbnail. So again, as an array of bytes. As mentioned just a minute ago, the code here isn't really that important, and it can easily be replaced with some other more complex logic. But if you're interested, you can see the logic in the make thumbnail function in the repository. So in the first step, we'll be deploying a web application that wrappers this make thumbnail function with some HTTP processing logic, which will allow users to upload an image through the browser. The web app will then call make thumbnail to generate the thumbnail and then return it back to the user. So of course, displaying the results in the browser. So we'll be able to see this in real time. So the first thing we're going to do to get started, we first need to have a Code Engine project. Now, a project is just a grouping of applications and batch jobs that have some sort of logical relationship to the developer. So, for example, perhaps they're all part of some product. All of the applications and different microservices for one product might be put within one product, Code Engine project. So how workloads are split across projects is really up to you. One thing to keep in mind is that workloads within a project can talk to each other over a private network, while talking across projects will not. So those workloads can only communicate with each other within the same project. So that's something to consider when you're grouping things. Okay, so to get started, we need to have a Code Engine project. So what I'm going to do is I'm going to create one. So go ahead and type IBM Cloud CE project create. Give it a name. And I'm going to call it thumbnail. Okay. All right, so Code Engine is creating my project right now, calling it thumbnail. Now, as my project's getting some up here, getting set up, a few things to consider as we're going to be working a lot more with these today. So by default, creating the project is going to select it so that all future IBM Cloud CE commands will be scoped to the project. So as you can see here, where it says now selecting project thumbnail. So it created and selected the thumbnail project for us. So now we are working within our thumbnail project. So in this, if you are using an existing project, you can select that through the IBM Cloud CE project select command. So in this tutorial, we've already pre-built most of the container images for you. So we can just go ahead and deploy our initial version of the web application by creating a Code Engine application. So before we do that, it's important to understand a bit about the different types of workload that Code Engine supports. So Code Engine supports two types of workloads, applications and batch jobs. So applications, like our web application we're about to deploy, are any workloads that typically respond to incoming messages, whether those messages are API calls, web page requests, events, or any other HTTP request. Applications process they process those messages. Code Engine will then scale your application based on the amount of incoming traffic to meet the demand. So it will also scale your application back down when there's a reduction in traffic, as I mentioned earlier, even down to 0 when there's no requests coming in. So this means that you only pay when your application is actually running and nothing when it's scaled to 0. Now, batch jobs are a little different from applications, pretty much in that they don't typically respond to incoming messages. They often are referred to as run to completion tasks. Batch jobs are meant to be created, then they execute some type of particular function, and then when they're done, they exit. So unlike applications, batch jobs will not automatically scale. The number of instances are specified when the job is executed. So aside from not receiving any inbound traffic, the mechanism by which they scale, aside from not receiving inbound traffic and the mechanism by which they scale, batch jobs are similar to applications in all other aspects. Okay, so we're going to go ahead and we're going to go ahead and deploy our application first. So the first thing that we're going to do is deploy an application. And to do this, deploy an application with Code Engine, we only need to provide two pieces of information. The name of our application, which is thumbnail in this case. You could name it anything you want. And the container image to use, which is IBM com/thumbnail. So this is a pre-built container image in a public container, registry, and Docker Hub. So the first thing we're going to do is type IBM Cloud CE app create name. We're going to give the name thumbnail, and then we're going to give it the image location, which is IBM com /thumbnail. Okay. So you'll notice that the end of the output, once we see it, it will be a URL. So what this is going to do is this is going to create our thumbnail application deployed to Code Engine. And what it's going to do is, there it is. It's going to return a URL. So this is actually where your application is now running. So what we're going to do is we're going to take a peek at this so that we can see our actual thumbnail application. So it was really that simple. So as you can see, with literally just two pieces of information, one being optional, which is the name, two being our container image location, we were able to deploy an application to Code Engine fairly quickly. in just a matter of seconds. So next thing I'm going to do, add this to the browser. And here is our deployed application. Let me make it a little bigger for you. Too big. There we go. So here is our thumbnail generator. Okay, so as you can see, it's a pretty basic application where you can drag and drop one of the images into the first box or upload your own image if you wish. So basically what you can do is just drag and drop one of these dog images, click generate thumbnail, and it will generate our thumbnail. I'm going to do a few more to take this one, generate a thumbnail for this one. See, so it's a pretty simple application, but we can test it out and see that we know that it's deployed to Code Engine because we just deployed it. And as you can see here, we have the URL here. One thing to note is that we get added security with our Code Engine application. So as you can see with the HTTPS at the top here, you can see our region that we selected for our IBM Cloud account, which designates the location for our project, and we have it deployed to Code Engine. So we've tested it out. We know everything works. Oh, sorry. Okay. So as I mentioned, with just the application name and the container image, we've deployed an internet-facing application that is secure, as we noted with the HTTPS and the URL, and it will scale up and down based on how much it is used. So not only was this simple to do, but it also completes the first part of the tutorial. So for the second part, what we're going to be doing is, now that we've proven that the logic of our thumbnail processor works, we need to change things a bit so that instead of assuming the incoming messages are coming from a web page, we're going to get them from a persistent store, or in this case, IBM Cloud Object Storage. So we're doing this because in our production environment, the data we're going to process might be coming from many different sources. So we need to keep both the original and processed data for our records. So this means that we need to save both the image and its thumbnail. So in the end, what this really means is that our web application might eventually go away, or could be just one of many ways in which our data store is populated. So its role switches from the processor to just a web front application. So the other change in processing logic we're going to make is to move the thumbnail processing out of the web application. Again, since it might not be the only way images are put into our data store, and into a separate workload that will invoke outside of the web app. But more on that later. So for now, let's focus on setting up the data store. Okay, terminal. Okay, we have seen the cool app. Okay, so we're going to create a new instance of Cloud Object Storage. So the first thing we're going to do is we're going to export the URL for our application as an environment variable so we can easily reference it later. There we go. Okay, so now what we're going to do is create an instance of Cloud Object Storage. There we go. So as that's getting started here. Okay, so from this output, you'll need to save the ID value for to use in the future for another command. So to make life easier, we're going to save it as an environment variable as well. This ID right here, the one that begins with the CRN. So we can do that by running export Cloud Object Storage ID or cost_ID and giving it the ID there. So the images will be stored in buckets, similar to folders in your computer. And to manage these, we'll use the Cloud Object Storage CLI, and we'll need to configure to it. So we need to point to our Cloud Object Storage instance that we just created, and tell it which authentication mechanism we'll use when talking to it, excuse me, since it supports multiple types. Okay. Excuse me. So first, we're going to direct all of our Cloud Object Storage CLI uses to our Cloud Object Storage instance. Okay. Yes, I have stored a cost instance before because I was running through this a little earlier, but that's okay. So now what we're going to do is we're going to use the IAM authentication method, which uses the same API key that the rest of our CLI commands will use. Okay, we'll do that. Move this up a little bit, easier to see. Okay, so we're going to run IBM Cloud cost config auth -- method IAM. So this is using the same API key that the rest of our CLI commands will use for the rest of our tutorial. Okay, good to go. And now, one final cloud object storage setup step is that we'll need to give our Code Engine project permission to access our Cloud Object Storage instance. By default, and for security reasons, access to your Cloud Object Storage buckets is restricted and cannot be accessed by any other cloud components without your explicit permission. In this case, we need to authorize access to your Cloud Object Storage bucket from your Code Engine project. So to do this, we'll first need the service instance ID of our Code Engine project. And to get that, we will use the following command. Oops. There we go. Okay. So we can type IBM Cloud CE project current. All right. So we can get the service instance ID of our Code Engine project. So if you look here, and then what we'll need to do is save the ID value corresponding to our project. So that's this ID here. So in order to save the value for the ID value for our project, we're going to save it as an environment variable called CE _ ID. All right. Okay. So we can now set up our authorization policy using both the CE ID environment variable we just obtained and the Cloud Object Storage ID, the cost ID from a previous command. So we're going to save the ID of this authorization policy so we can delete it later at the end when we're getting rid of our provisioning instances. Okay. All right. So we're going to save that policy ID. As you can see here, we have the ID here. Okay. So the next thing we're going to do is now we can get back to setting Cloud Object Storage up for our application. So First, we're going to go ahead and create a new bucket into which our data will be stored. So to do this, we'll need to provide a unique name for your bucket. And this is important. So it needs to be globally unique across all buckets in all of IBM Cloud. So what we're going to do here is we're going to just use the source service instance value from the previous command's output. This just happens to also be the ID of our Code Engine project appended with -thumbnail. So as you can see here, so as not to get confused, we saved our authorization policy with the environment variable policy ID, and our bucket environment variable we are saving with the same, our source service instance, which is also the ID of our Code Engine project, and we're just appending it with thumbnail. Okay. You can technically use any value you want as long as it's unique. This just makes it a little easier than trying to type in a bunch of random numbers and appending it with thumbnail. So now that we saved it in environment variable, we can use it much easier. Okay, so next we're going to ask Cloud Object Storage to create our bucket. With IBM Cloud cost bucket create, the name of the bucket is bucket from our environment variable that we just created. So we're going to create our bucket here. Okay, good to go. So this actually completes part 2 of our tutorial. So now we can continue with our application's migration. So with our data store ready, we can now deploy the second version of our application. This version looks very similar to the first one, but instead of calling the make thumbnail function immediately, it'll put the uploaded image into our bucket, that bucket that we just created. We'll invoke the make thumbnail function at a later point in time. So as with the first version of our application, the container image is already built for us. So we just need to tell Code Engine to use it. However, there is one other change we need to make at the same time. This version of the application will need to be told which bucket to use for the images. So it'll look for an environment variable called bucket to get the bucket name. We could have just hard-coded the bucket name into the application, but being able to modify the name dynamically without changing the source code is a much better way to operate. So, however, before the application can access the bucket, it'll need a little bit more information about how to talk to our Cloud Object Storage. For example, it'll need the credentials to authenticate to our Cloud Object Storage instance. Code Engine can help here by setting up the credentials and auto-injecting them into the application as environment variables, which is a really fantastic feature of Code Engine that you can also do from the UI. So if you look in the main function in the source code in the v2 app.go, you can see the first thing it does is it gets those values for later use. Okay, so, and if you take a look at that, at the function, you'll see it will get the API key used to access the Cloud Object Storage and the Cloud Object Storage instance ID for our bucket. So the next thing we're going to do here is in Code Engine, we use the bind operation to connect our workloads up to service instances. So all we need is the application name and the service instance name that we used in the resource service instance create command in the previous section. And Code Engine will then inject these environment variables for us. So as you can see here, we're using IBM Cloud CE app bind, using the name thumbnail of our application and the service instance name thumbnail cause that we created when we created our Cloud Object Storage instance. Okay. All right, let me just take a check here, make sure we're all good. Okay. Should be right. Okay. So you can see here, we're creating our service binding service ID, creating service binding API key. And now we're waiting for the application revision to become ready. So notice that it's deploying a new version or revision of the application. That is going to happen. Oops, there we go. That is going to happen each time any change is made to an application. So if the application is in the middle of receiving requests, then it will not send new requests to the new revision until it successfully comes up and is ready. Only then will Code Engine migrate all the traffic from the old revision, to the new one. So as you saw yesterday with version 1 and version 2 of our HMO app, we were able to watch in the UI in real time Code Engine migrate all the traffic from the old revision to the new one. So this means that users of your application will never experience any downtime during this switchover. So eventually the old revision of your code will be scaled down. So even though we haven't upgraded our application code yet, having those cloud object storage and bucket environment variables already set doesn't hurt. So now let's go ahead and upgrade to the latest V2 version of our application. And remember to pass in the bucket name as an environment variable. Okay, so as you can see, we have IBM Cloud CE app update, the name of our application thumbnail, the image location, our V2, and our bucket, the value for our bucket environment variable. Okay. And voila. So notice that the application has been updated. So you might have noticed that the web page looks a little bit different when we go over here. Okay. Just to show you a difference here. As you can see here, we've refreshed to V2. No downtime, no cold starts, no waiting for things. Just wanted to show you the UI changes, a little bit of changes that were made. So there's a few things to be aware of. Dragging or uploading an image into the leftmost box does not upload it automatically to the server, which is our object storage. You're given an opportunity to view it first. So when we drag this guy here, okay. Once you're okay with the image, then you can press the upload image button to upload it to the object storage. There we go. Okay. So now that we've selected the image, we like our image. We can see the image in the images/thumbnails box on the right. So, however, the corresponding thumbnail image should show not available until you ask for the thumbnail to be generated. So right now we've just stored the image. I haven't asked it to generate the thumbnail for me. You can upload as many images as you want. So I could upload another one here. Okay, and as you can see, both the images have been uploaded. The thumbnails are still not available. They're not going to generate until I run the thumbnails job runner button. So we're going to generate thumbnails with this thumbnails job runner button. But as you can see, it's not doing anything. It hasn't been enabled yet. So that's what we're going to do next. And then finally, you'll notice a clear bucket button, which can be used to erase the contents of the object. I can speak. The clear bucket button can be used to erase the contents of the object storage bucket if you would like. So the next thing we're going to do, so technically you can use the application right now, but if you upload an image, you're not going to see the thumbnail because that logic has been moved out of the web application, as we mentioned previously. So before we had a web application that also contained the operational logic. We've since moved that out of our web application, so it's a standalone web application. So the processing of images is now going to be done in a batch job. And as we mentioned earlier, batch jobs are pieces of code that will run once and then exit when done. So unlike applications that wait for additional work to come in through HTTP requests, in this case, we've moved that make thumbnail logic out of the web application and into a separate container image, which if you're interested, you can also see in the repo at in the thumbnail tutorial under the v2 /job.go file. Like other images, it's been pre-built for you. So all we need to do is create our batch job. Okay. So where is my terminal? Okay. As you can see, we can see the app, but it's not, the job is not connected yet. So next thing we're going to do is create a batch job. So before we run this, just to, it's important to understand what's going on here. So the arguments to the job create command are, we have this thumbnail job right here. This is the name that we're assigning to this job. Then we have this IBM Com thumbnail job. This is the name of that pre-built container image that we're going to use. And then we have our bucket. This is the environment variable that the code will look for to get the name of the bucket in which the images are stored. Same as with the application. It's important to note that the previous command just defines the job. It doesn't actually execute it. So this command here. So we're creating a job, but we're not executing it. So this command just defines the job. By creating the definition of the job in advance, we can easily run it whenever we need to through a job submit command without having to enter all the parameters each time. So in our case, the web application will be submitting the job for us each time the user presses that job thumbnail runner button. So each time you press that job thumbnail job runner button, the web application will submit the job for us to store those images. Okay. So, okay. So as with the application that we saw earlier, the job will also need credentials to talk in order to talk to the cloud object storage that we provisioned. So we'll need to issue another bind command to ask Code Engine to auto-inject those credentials for us. So if you go back to the web page, you'll be able to generate thumbnails for the images you upload by pressing the job runner button. Once we bind our once we bind our job and auto-inject our credentials. Okay. So we should be able to go back to our application as soon as this is finished. All right. So now when we press the thumbnail job runner, it'll take a second or two. But once the job is started, it's going to do the work, and then we should eventually see the thumbnails appear on the page. And there we go. Okay. Again, just to recap, when we press the thumbnail job runner button, the web application submits the job. Excuse me. And to do the work of creating the thumbnail with that make thumbnail function. Okay, very cool. Let's try another one. Let's try this guy. This guy looks like he's having a tough day. So again, I can upload the image. And when I click the thumbnail job runner button, the web application is submitting that batch job. It'll take just a minute for it to complete. And there's our thumbnail. We can also clear our button. Sorry, clear our bucket. All right, so I'm gonna pick some guys I don't normally pick. So as you can see it in action, we can do a couple. So I'm gonna upload this one. I'm gonna upload this one. Oops. Oh, well, as you can see, you can also add images of your own. I don't have any prepped and ready, but and this guy, I like this guy. I think his little ears and his tail are so cute. So as you can see here, I've uploaded 3 images. And when I click this button, the web application will submit the job, and it will once it's completed, it will generate thumbnails for all 3 of the images. Okay. So in the last part of the workshop, we're going to make the final migration to our application. So as of now, the application is more robust than it was when we first started, right? It can save images as thumbnails. It can support processing images regardless of how they're put into the data store. So we can drag and drop. We can upload our own images. They can come from different sources. It can process the entire bucket of them at will via our batch job. So we don't have to do just one at a time. We could do all of the images at once, and then press the thumbnail job runner to submit our batch job and run all of them at the same time. We could hook it up to a timer-based invocation mechanism, and that's appropriate for some systems, but for our needs, we want it to be a more reactive or event-driven. So in other words, our requirements are that we'd like to have each image processed immediately as it is uploaded into our Cloud Object Storage. To achieve this, we're going to have Cloud Object Storage send us an event each time there's a new image uploaded into the bucket, regardless of where it's coming from. And then we'll process the image right away. So you'll see it instantaneously. In order to make this happen, we're going to have to deploy a second application to receive those events. So we could have reused the web application for this, but in order to have a clear separation of concerns, we're going to create a new one, and then each can scale independently as needed. Okay. Oops. Get rid of this. Okay. Okay. So let me pull my terminal back up here. Okay, so rather than using a pre-built container image, this time we're going to leverage Code Engine's build feature and build it ourselves. So in order to do this, there's a little bit of setup we need to do. First, we'll need to create a place to store our newly created container image. We're going to use IBM's container registry that we talked about earlier, or ICR. So in there, we'll first create a namespace, which is similar to a folder on your desktop, to place our image. Namespaces in ICR IBM Container Registry must be unique across all users in a region. So we need to make sure that we use a unique name. So for our purposes, we will prefix a human readable name with the ID of our Code Engine project. To do that, we can reuse the first 8 characters of our CE_ID environment variable we already created and create a new environment variable called ICR_NS, which we're going to do here. So as you can see, we have the first 8 characters of our CEID appended with thumbnail CS. Okay. Now we're going to go ahead and create the new ICR IBM Container Registry namespace. Okay. Okay. So if you are running the tutorial outside of the US, any of the US regions, then the location of your IBM Container Registry server will not be the us.icr.io in the output from the previous command. So as you can see, I was using an EU-GB region. So the output, the registry I'm using is actually UK-based IBM Container Registry. So to keep things generic or easier, we're going to set the ICR environment variable to the location of your ICR server so that we can use it whenever we reference images that you're going to build for the rest of the workshop. Okay. Next, we're going to need to create a set of credentials that our build process is going to use to talk to the registry. So we will give those credentials a name, the name of thumbnail ICR API key. As you can see here, API key create, thumbnail ICR API key. This will also make it much easier for us to delete it later when we're all done. Okay. So the final setup we need to do is we need to tell Code Engine how to talk to the registry on our behalf using the API key that we just created. So to do this, you'll need to copy the API key value in the sample, like you can see here. So here's my API key here. So you'll need to copy the API key from the previous output into the following in place of the API key. Okay. So what you'll do is here where it says API key, you're going to just replace that with your actual API key value here. Okay. Okay, so now we can actually define the build process of our new container image for the new application. So the parameters for this command are, we have our name, which is the name of the build definition we're setting up, our eventer build. The image, which is the name of the container image we're going to build, which as you can see here is this ICR_NS eventer. Notice that it includes the name of the ICR IBM Container Registry and the namespace, the IBM Container Registry namespace that we created, and finally the name of the image of the image itself, which is this thumbnail eventer. So the source, this is the location of the Git repo where our source code can be found. So if you see the source right here. And the registry secret. The registry, this is the registry access secret that we just created in the previous command. Right here. And then we have our context directory. This is the location in the Git repository where our code resides. So if it's at the root of the repo, then this parameter would not be necessary. So that just means that within our Code Engine repository, we need to get our source code from the thumbnail directory. If it were in the main, for instance, if the source code were within the main Code Engine repository, we would not need to add this context directory at all. Okay. So we're going to run the command and define the build process. All right. So similar to the batch job we created, this here. There we go. So similar to the batch job that we created, this command just defined how to do the build. It didn't actually invoke it. So remember when we created a batch job, we created it, but then we had to actually submit our batch job to run it. So this allows us to run it over and over without needing to specify all of the parameters each time. So what we're going to do is we're going to invoke it via the build run submit command, and we're going to pass in the name of the build that we just created. So this eventer build that we just created. Okay. So we're also using the --wait flag at the end here. So we can see the build output as it happens, and we'll know when it's done. Okay. So once we've submitted this build run, once it's finished running, we can finally deploy our new application. There we go. Now we can finally deploy our new application to receive the events. So you'll notice in the command here, it looks very similar to the app create command. It even says IBM Cloud CE app create and asks for a name. Oh, sorry. But there's a few more parameters than the name and the image, as you can see here. So it's a little bit different. So the first difference is the registry secret, which we have here. Right? So we have a name and an image just like an application, but we have also our registry secret. Similar to what we did during the build process, we need to pass in the credentials to our private IBM container registry namespace so that Code Engine can actually access the image. There's also a cluster local parameter. And this is this last, I see it, cluster local here, okay? And what this is doing, get this started. This is just telling Code Engine to make our new application private. So this means there is no external internet-facing endpoint available for it. So by doing this, it's only going to be accessible to other workloads within our Code Engine project, like we mentioned earlier, and to the Code Engine eventing infrastructure. Since the only incoming traffic will be events from Cloud Object Storage, we don't need it to be visible outside of our project. So this only impacts incoming traffic. The application is still able to initiate connections to the internet if it wants to. So now we've created our application. Let's see. So as you might have guessed, just like the first application in the batch job, the eventer application needs credentials to talk to cause as well, as you can see here. So what we're going to do is we're going to bind it to the cause instance. So we're going to bind the credentials to our Cloud Object Storage instance. Okay. And then there's one last thing that we need to do. We need to tell Cloud Object Storage to send an event to our Eventer application each time a new image is uploaded into our bucket. To do this, we're going to create a subscription. Now, a subscription is just a request to receive events from a particular event producer, which is Cloud Object Storage in this case. You can see it. There you go. And the parameters that we pass to the subscription create command are, as you can see here, the name. This is the name of the subscription that we're giving it. The bucket. This is the name of the bucket that we want to watch. It's our bucket that we create an environment variable for earlier. And then we have the destination. So this is the name of the application that we want our events sent to. So Eventer in this case. So we're going to go ahead and create our subscription. As you can see, we're creating our Cloud Object Storage event description called Cost Watch. Okay. So we'll wait for this to finish. Oh. Interesting. Let's see. All right, hold on. Refresh here. Okay. So I'm going to do. Oh. Okay. 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 Sorry, I think we're starting to get a storm here. I think I might have lost. Make sure everything's still going. Okay, we're still going. Okay. So let me just back up for just a second. Okay. Yeah, it looks pretty bad out. Okay, sorry about that. It's getting pretty dark and scary. Okay, so while everything's hooked up, as you can see here, you'll notice that the thumbnail job runner button is still visible, even though it shouldn't be needed anymore. So, however, instead of completely removing it from the code, we allowed for it to be conditionally visible with another environment variable called hide button. You can see here. Okay, so this is IBM Cloud CE app update, our thumbnail application with the environment hide button, and we're updating our hide button environment variable to true. So if it's set to any non-empty string, then the button should disappear from the web apps page. So what we're going to do is upload our application with this IBM Cloud CE app update, which we did here, as you can see. So now we can go to our application and upload an image. So I'm going to clear my bucket. All right. I'm going to add, click upload image. Oh, and it did too. So, okay, we're wrapping things up here. So before my power goes out, I promise we'll finish. Okay. So as you can see here, so when we upload an image, we are able to see the thumbnail automatically be created without the need to press the job runner button. And with that, we've completed part 4 of our tutorial. So the last part of the workshop doesn't involve learning anything new about Code Engine. First, we're going to demonstrate how the event-driven thumbnail processor works without even uploading images to the web application. So we're going to download an image to our local system by using one of the predefined images from our web application. So to do that, we're going to run this curl command you can see here. Oh no, okay. Not sure what happened. So this curl command here, actually, you know what? That's why we saw 2 here. So actually, while I was uploading this image into our bucket, I also ran the command from the command line, which uploaded the image to our web application with the curl command. So we're able to see that here. We're able to see it automatically appear on there as the web application refreshes. You can still upload images from the web application too, if you'd like. Either way, the eventer application will receive the event from Cloud Object Storage and process the image. And you can still use the clear bucket button on the web application if you'd like to erase the contents of the bucket. So the last part, as you can see, is already happening here, is the cleanup. In the slides as well, so let me go back here. I'll find them for you. Okay. We have all of the commands to clean up everything. So it'll delete our Cloud Object Storage, our thumbnail application, our IBM Container Registry namespace. It'll also delete your Code Engine project and everything for you. Let me just go back here for a sec. So this concludes the hands-on portion of our workshop. So as you can see, we can choose an image from our local directory. We're able to use the curl command from terminal to send an image to our thumbnail generator, which automatically uploads our image and also generates the thumbnail instantaneously. So we didn't have to do any of that. Let me just check here how you're all doing. All right, looks like you're all doing pretty good. So let's see, we'll move down here. So we have a few minutes. I will go to talk a little bit more about Code Engine for all of you, give you a little bit more highlights, a little bit more information as to why it might be the best option for you as a developer. So at a high level, Code Engine is a merging of all the various as-a-service containerized platforms merged into one. So whether your workload or container is going to be running a function or a service function, whether it's there for a platform as a service type application, such as web apps or 12-factor applications, whether you're running a bunch of batch jobs that don't respond to HTTP requests, or you're responding to HTTP requests like eventing that we just saw. It doesn't matter. As long as you containerize your workloads, Code Engine can run it for you. And it's going to run it in the cloud and manage all of the infrastructure behind the scenes for you. So it's just a matter of managing, it's not just a matter of managing infrastructure. It can also present a simplified developer experience for you. As you saw yesterday in the part 1, where we did everything from the UI, you're able to see how quickly and easily you're able to do things. And it's a very simple and I think pretty nice experience as a developer using cloud technologies in a console. So even though Code Engine is running Kubernetes, Knative, Istio, and other open source technologies under the cover. You don't need to know that they're actually there. So you don't have to worry about learning kube control and learning how to talk to Kubernetes and all that other infrastructure stuff. Code Engine has simplified everything to the point where you only need to focus on giving the inputs of what you actually want to deploy. So this means if you give Code Engine your source code, if that's where you want to start your workflow, or your container image, if that's where you want to start your workflow, it's completely your choice. You just indicate the runtime semantics that you want for your workloads. And this means, do you want it to scale based on load coming in or a certain amount of memory? If you tell Code Engine the raw numbers and runtime semantics you want, Code Engine will then figure out how to make the infrastructure match your desired semantics. So you as a developer can basically just dump your information into Code Engine and say, hey, go run this for me. And you can get back to coding, which is where you want to be spending most of your time as a developer. You do not need to spend time learning Kubernetes and how to manage Kubernetes clusters and pods and anything else related to the infrastructure. You can just worry about building out the actual functionality of your application. So let's talk about what you can actually do in there. If you take a look at the blue box here, Code Engine is a managed platform as a service, a serverless managed platform as a service. In the cloud, it will auto-scale your workloads for you, and not just the application, the Kubernetes clusters that are running under the hood as well. So Code Engine will scale that out for you, and you only pay when your applications are actually running. So you're not paying to be running infrastructure and provisioning and pods and clusters when they're not actually in use. If everything scales down to 0, you're not charged at all. Code Engine also supports scaling out based on resource usage. So instead of the number of requests coming in, Code Engine will scale out up or down your applications and workloads based on CPU and memory usage. So as we saw, Code Engine provides built-in security for your applications automatically, and you don't have to worry about setting up any of the SSL certificates, managing the load balancers, managing runtime isolation between various workloads running in the cluster. Code Engine takes care of all of that for you. It'll also build your images for you if you want to start with source code in a repository. You can integrate any IBM Cloud services, and not only can you talk to them, you can tell Code Engine which ones you want to talk to, and it will inject the credentials and the coordinates of your instances into your application. So your application doesn't have to figure out where your credentials are, what secrets they're stored in. They'll be available to you as environment variables automatically. And unlike other platforms where there's going to be limits in terms of how long your things can run for, how much memory they can use, Code Engine doesn't have those limits. So if you want to run something for 12 hours, go for it. If you want to run high memory applications, go right ahead. We're not going to stop you. So unlike other platforms, Code Engine doesn't have those artificial limits imposed on you. So to all of you, I'd like to say congratulations for completing our IBM Code Engine 101 and 201 workshop series. If you would be so kind, I will share this with you as well. I have a very brief 2-question survey. Feel free to share any information, maybe what IBM services you would like to see integrated into Code Engine projects, what types of projects you would like to see. I'm working on an e-commerce application right now. Maybe that's something we could workshop in the future. So any tech stacks you want to see, any coding languages that you're building with that you'd like to see some sample applications for, please feel free to share. I also would like to remind you all that the Code Engine 101, if you're joining from Crowdcast, you can actually click at the top of the screen to access the 101 live stream recording. That was yesterday. And if you're joining from one of our other IBM developer, sorry, if you're following us on one of our IBM developer social channels outside of Crowdcast, you can access this recording as well as the 101 at crowdcast.io/e/IBM Code Engine. And you can, the forward slash is for the 101 and /2 is for the 201. So you can access everything there. Feel free to reach out with any questions. Feel free to stay connected. I also, as always, have all of the resources available for you. All of the event resources at the end of the slides. All of the different cloud certifications that are my personal recommendations. And all of our IBM developer social media sites where you can follow us all, and also check out all of the workshops and things that we're running. So whenever I run a workshop, I multi-stream to all of our social channels so that you can join us and learn in an environment that's most comfortable for you, where you like to be at digitally. So I'd like to say thank you all so much for coming. I hope you all have a wonderful, wonderful rest of your week, and even happier Hacktoberfest. And I will see you throughout the rest of the month with some more great Hacktoberfest workshops for you. So thank you all so much for coming, and I will see you all next time. Have a great weekend.